This is yet another video where I experiment with data like I know what I'm doing, so that someday, maybe, I do know what I'm doing. I've thought about this project for a while, and although the final results aren't so impressive, I learned a lot, and there's a lot to talk about. So let me tell you about making a Squid-Maker. I've been making these videos for more than a year. I've got hours and hours of content, and although the subject matter is all over the place, it's conveniently formulaic. The right quarter of the screen almost always looks like this, or this, or this. I, the Squiddy boy, have little variation in my expression and the position of my tentacles. Personally, I like being this Squiddy boy. I have 6 expressions: neutral, happy, sad, mad, curious, and surprised. I can make those expressions toward you, the viewer, or looking to the side, toward the screen. And I have 7 tentacle positions: neutral, pointing to screen, pointing up, pointing in, touching, reading, and thinking. There's more to it than just that. I have a profile view I rarely use, and I can combine expressions or tentacle poses to make more complicated ones. I can tilt my head, and I have lots of ways to point at things. But ignoring these rarer expressions, I only have 84 possible squids. Making these squids is the last step of making a video. Before I decide what the Squiddy boy looks like, I write the script and record it, and collect and edit and organize all the clips I plan to use. By then, I have a pretty good idea of how my squid will be reacting. But what if I didn't have to make my own squids? What if the computer could do it for me? Say, based on the audio of my voice. I downloaded all of my videos from YouTube. Then I wrote a Python program to look through every video and pluck out the squid at regular intervals. It only kept every 10th row and column of the image to reduce file size. Then it found the average of all those images, which looked like this, sort of ghostly. It compared this average to every image to remove the ones which seemed out of place. It wasn't perfect. I had to bring back all these images where I'm holding a book, and had to remove the images with rare expressions or tilted heads myself. But it helped. Then I went back to Python. Each squid image was named after the video it was taken from and its timestamp within that video, so the Python program could find the audio before and after each one. So now I have thousands of squids and their associated audio clips. A squid picture is a 108 by 48 matrix with 3 layers, and its every element is an integer between 0 and 255. The 3 layers describe how red, green, and blue each pixel is. The audio is a bunch of numbers, and the numbers make a wavy thing which vibrates your eardrums. I'll be honest, my only qualification to talk about audio is that I'm really good at whistling, and my dad played the banjo. What's important is that I can make audio into numbers, and then make the numbers back into audio. So the information is definitely in there, even if it's in a format humans and squids can't parse. I can even decrease the audio quality by skipping numbers. Check it out. Rubber baby buggy bumpers. Rubber baby buggy bumpers. Rubber baby buggy bumpers. Rubber baby buggy bumpers.
Rubber baby buggy bumpers.
Finally, I normalized all the data. I found the average and standard deviation of elements making up the squids and audio clips, and from every element I subtracted the average and divided by the standard deviation, so both the datasets had an average of 0 and a variance of 1. Computers tend to like data better that way, and I can unnormalize the data at the end. All this stuff takes forever to do. I don't want to do it again every time I start over, so I take these big data sets and, you're never gonna believe this, we're gonna make it into a pickle. Funniest thing I've ever seen. Now I want to make a deep machine learning algorithm which uses audio to guess what the squid looks like. I tried running a neural network on the data as it is, but that froze my computer. 108 times 48 times 3 is almost 16,000 outputs to predict. And with the seriously dense audio input, I'm asking the PC for something beyond its capability. So I made an auto-encoder. An autoencoder is a machine learning algorithm which accepts inputs and turns them into the same inputs. That seems kind of pointless, but the important part is this bottleneck here. Through the autoencoder, a squid is reduced from almost 16,000 pieces of information to, say, 25 numbers between 0 and 1. Those 25 numbers are then reconstituted into a whole squid. Splitting the autoencoder into an encoder and a decoder, we've got a nice way to talk about data-heavy squids in a concise format. But my autoencoder didn't work. What's up with all these speckles and spots? After much frustration, I realized I'd used the wrong activation for the last layer of the autoencoder. I had used an activation from my video about natural language, which only output values 0 or above. After normalization, the elements of my squiddy boys have an average of 0 and variance of 1, so about half of them were negative. There was no way for my autoencoder to replicate that, so it did so spottily. After changing the activation, the autoencoder worked pretty well. And now, training a deep neural network to turn audio into squid pictures won't crash my computer. Its test accuracy is awful, but let's judge the performance ourselves on the audio from my intro video. My intro video uses a lot of head tilting, and I throw away a bucket of popcorn, so obviously the algorithm can't replicate it perfectly, but let's try anyway. The original squid is here, and my algorithm's guess is here. Sometimes pop culture, sometimes data science, and always the relationship between storytelling and our perplexing existence as sentient beings. I don't need, or even expect anyone, to offer me free money on Patreon, but I wouldn't turn it down, and I'd put your name at the end of my videos. So, obviously it's not working. The squids made by my algorithm have transparent parts and ambiguous faces. I'd like to say that the transparent limbs mean the algorithm was hedging its bets, guessing the midpoint of its best predictions, but the low test accuracy makes me skeptical that there's really any valuable information here. Luckily, the autoencoder alone is still totally neat. I made another program which makes widgets, little slider bars, so we can slide up our own lists of 25 numbers between 0 and 1, and see what kind of squid they make. By playing around, we can understand how a squid's parts are reduced and reconstructed. Like, when this slider is high, the squid looks forward. When this slider is low, the squid looks aside. I feel like I could encode a squid myself more efficiently than this. So let's try again. I made another program which showed me one squid at a time, and let me use widgets, little toggle buttons, to give each squid a list of 14 zeros and ones. These aren't numbers between 0 and 1, but binary zeros and ones. So this first digit is a 0 if the squid looks one way, and 1 if the squid looks the other way. These zeros have 1, 1 to show the squid's emotional state, and these zeros have 1, 1 to show the tentacle pose. I encoded about 1,000 squids myself, then trained a deep algorithm to encode the rest of the squids based on how I did it. The algorithm had pretty great test accuracy, so I'm assuming it did a good job. Now I can train the audio-to-squid network again, but instead of trying to output a whole squid, or even a squid encoded as 25 ambiguous numbers between 0 and 1, its goal is a tidy 14 zeros and ones which have explicit meaning to us. But look at this output. These aren't zeros and ones. Like before, the algorithm isn't able to listen to the audio and say, that's a happy squid reading a book, or that's a sad squid with its tentacles up. It's hard to even say that it hedged its bets. I wrote some extra code which turned this output into the squid it seemed to be implying, but I still wasn't happy with the ambiguities. I tried dozens of different parameters, but I never got a Squid-Maker to do it the way I would do it. That's the lesson to be learned, I think. I was hoping that the audio of my voice would have enough information for a computer to say what my squiddy boy looked like, how it was feeling, what its tentacles were doing. But now I'm sure that's a losing battle. My squid's expression might actually be the polar opposite of the emotion in my voice, because my sense of humor is way sarcastic. Maybe my voice sounds different when I'm reading from a book, but sometimes, like right now, I'll hold a book even though I'm not reading from one. And the direction I'm facing is probably more related to what's currently on screen than what I'm saying or the way I'm saying it. No matter how cool machine learning is, it's not magic. But that doesn't mean I didn't learn a lot. I'd never made an autoencoder before. I'd never worked with video or audio in Python like this. I'd never made such a complicated data pipeline with widgets and stuff to boot. I want to keep failing upward, faster and faster. That's the way I think here at Thinkster. This whole quarantine thing is making me a little stir-crazy. Sure, I've got plenty of time to play with my computer, but when I get frustrated with my computer, I can't calm myself down by coughing on strangers. How are you holding up? Hope all's well. Bye-bye.